So like this. Okay.
So good afternoon. Can you hear me okay at the back? Great. So my name's Professor Jem Bendel, and I'm delighted to be with you today to chair and speak at a panel on what we're calling climate honesty, ending what we also call climate bright-siding. And I'm very pleased to be here with Dr. Ye Tao, who's going to be presenting about the MEER framework, and also to be here in collaboration with Facing Future TV. There's an article in The Guardian today about the big word on all scientists' lips, scary. And it's difficult to be scared all the time. But emissions are up, atmospheric concentrations are up, temperature, sea levels, hunger, they're all rising. We know all of that. And there's also something we know which is far more incriminating of all of us here, which is the talks and agreements at the UNFCCC over the past decades have not managed to change any of that. Instead, they consistently move the goalposts. Back in May '92, when the UNFCCC was formed, member states agreed to cut emissions to stabilize atmospheric carbon at 354 parts per million by 2000, 22 years ago. But annual emissions climbed 65% last year. 65% since then, and we're at an all-time high last year. Back in 2009, the world's climatologists, the top ones of the world, got together and issued something called the Copenhagen Consensus that said if global emissions had not peaked by 2020, we would face inevitable catastrophic changes. But annual emissions, as I've said, continue to rise. So they might continue to move the goalposts, but we can't play games with nature. Nature will always win, because nature actually owns us and not the other way around. Faced with the bad news, some experts are asking myself and my colleagues to calm down. They finally admit that, okay, it's already worse than we thought it would be, but don't worry, it's not going to be as bad as we thought it would be. They say we just need all societies on the planet to throw their emissions into high-speed reverse, have negative emissions technologies prove all independent analysis right and actually be useful, and also be blessed with some climate luck from the ecosystems that we've already disturbed being friendly to us rather than amplifying what we've done wrong. Opinion surveys now regularly show that vast numbers of people don't believe that that's going to happen, especially the young and increasingly numbers of people across the global south. In response, we see the professional talk shoppers criticize folks for being too negative. But people losing their livelihoods or being displaced from their homes are not going to benefit from such stubborn optimism from the professional classes. Rather, this kind of climate bright-siding, where we're made to doubt what we can now see with our own eyes, is actually limiting our conversation on our scope of action and our urgency. It means we don't support disaster risk reduction as much as we might. We don't support adaptation and reparations as much as we might. It means we don't support rapidly deployable technologies that could help people who will suffer the most and the soonest, which is something we're going to hear about today. It also means, though, we don't question the power structures that are sending our children into this hellscape. And it means we don't abandon all the old ideas about ourselves and our work. Therefore, we don't allow ourselves to become much more radical in how we respond to the climate crisis. So as I said, it's difficult to be scared all the time. Complete climate honesty is painful and it's going to get more painful, but it's necessary to try to reduce the harm. Today we're going to hear from Dr. Ye Tao about some of the awkward science on climate change, currently ignored, about a net zero paradox, and a new initiative that seeks to reduce growing suffering that he founded. When working at the Rowland Institute of Harvard University, Dr. Tao realized just how bad the climate crisis was becoming. So in 2020, he left what he was doing and founded the MEER framework. It's his response to his understanding of the accelerating and ultimate consequences of the climate crisis on our delicate web of life. He comes at this with a very relevant education as a biochemist, physicist, materials scientist, and he brings the benefits of that multidisciplinary background in engineering and in science to his new work in the climate crisis. So I'm very pleased he's going to present to us for a few minutes now. Thank you. Yeah. Put it on the desktop.
Well, thank you, Jim, for that introduction. So indeed, we really need to be telling the truth, the full truth of climate catastrophe and the state of the world before we can come up with very effective solutions, engineering solutions to combat the crisis. So today I'll be telling you about a technique that's based on MEERs that can simultaneously provide food system security, better shelters when there's a heat wave, and also much better access and the preservation of water resources. But before, the first point I want to hit is that we have another degree of warming in store for us, and that the IPCC has been downplaying this inconvenient truth. So when we burn fossil fuel, we not only emit the long-lived greenhouse gases, but also short-lived aerosols that interact with clouds and promote brighter clouds to cool the climate. And the result is that we don't experience the full impact of greenhouse gases, but rather the difference between the greenhouse gases and these cooling aerosols. So in the future, when we do indeed achieve 100% carbon neutrality, what would happen is that, at least in the short term, there will be a much larger amount of positive reinforcing heating the planet. So COVID-19 provided an opportunity to interrogate what happens when you have a sudden increase in the amount of heating power driving warming on planet Earth. So we had about 7% over the year of reduction, but it happened different times on different continents. So we know the dates of lockdowns, so it's sort of a random controlled experiment that we can interpret. When visible light reaches the ground, it becomes absorbed as heat. And indeed, in much of Europe, for example, we observed record levels of shortwave radiation reaching the ground. And in Asia, for example, in China, the increased radiation also led to increase in ground land surface temperature, which then drove stronger circulation patterns, leading to a record precipitation in recorded recent history. And this record-breaking event, scientists were able to attribute about 30% of the anomaly to the disappearance or temporary disappearance of aerosols from the burning of fossil fuels. And very recently in the United States, forest fires have also been partially linked to a reduction of emissions during COVID lockdowns. And curiously, the temperature anomalies, the precipitation anomalies, and also the humidity anomalies were all attributed to about 30% were linked to the aerosols. We don't know where the remaining 2/3 are coming from. We might come back to this later. But in summary, in 2020, it was a really record-setting event where many parts of the world experienced extreme hurricanes, temperatures, and floods. So since it appears that this aerosol component and perturbation to the aerosol is so important, it's quite important to understand how much there actually is. So our best understanding up to 2021 was that there's about 1 watt per meter squared of warming masked by these aerosols. And if we consider the translation from the heating power to temperature at an equilibrium state, we know that roughly that translates to 1 degree Celsius of warming that's still in store. And the field studying this phenomena goes back to the 1920s. And we continue to make new progress. For example, last month, we discovered that even though sometimes shipping lanes, when ships, they go over oceans, they create clouds sometimes, but sometimes they don't. But even when they do not create visible clouds, those tracks still contribute to cooling the planet. And we could be underestimating the cooling power by another watt per meter squared, which is very scary indeed. And the history of the IPCC has been consistently underestimating how much cooling this pollution is providing. So in the assessment report 5, the center value was 0.9 watt per meter squared, that's hidden. But by AR6, it was up to 1.3 watt per meter squared, that's hidden. And in the curious special report, 1.5 degrees, in order for the resulting temperature curves to not cross 1.5 degrees very quickly, the modelers arbitrarily chose 0.7 watt per meter squared, even though that's contrary to evidence and everything we know. Not only did they have to arbitrarily use a smaller input parameter, which we know is false, they also had to shift the baseline down by about 0.15 degrees, just so that we do not have immediate crossing of 1.5 degrees when the simulation simulates a stop to fossil fuel emissions. So basically 1.5 degree target is dead, and 2 degree target is also dead. But yet, we still say that mitigating greenhouse gases is the only tool that's allowed, and that's problematic. And we know that as we continue to decarbonize, which is necessary, we will expose the vulnerable populations in the world, in India, in China, and in Southeast Asia, and in Africa, to the worst impacts, because there's more pollution there, so as we clean up, they will be exposed to more warming. So what do we do? So, for example, let's put some mirrors on the roof. So we did this experiment in California, and we discovered that just by putting these simple passive reflectors, we can decrease roof temperature by up to 30 degrees. We can also decrease interior temperature when there's no insulated roof by about 5 to 15 degrees. And that can mean the difference between life and death in the global south, where temperatures are already increasing beyond 50 degrees Celsius. And even in well-insulated global north buildings, we can still measure an internal temperature decrease of 1 to 2 degrees Celsius. There's also opportunity to apply MEERs to save water. So currently, we're losing about 300 cubic kilometers of water just from our reservoirs. And the terrestrial water storage deficit in agricultural areas is about 120 cubic kilometers. So if we could just prevent less than half of the fresh water from just evaporating away, we could do a long way to solve the issue of water scarcity. So we performed the experiment, floating MEERs on the water, above the water, and below the water. And in all cases, we observed dramatic decrease to the rate of water losing. So in the raw data shown in gray, you may be wondering what those spikes are. So it's actually squirrels in the neighborhood coming to have a drink of water. And they seem to also prefer the bin with water compared to a bin with the bin with MEERs floating on top compared to MEERs that's submerged. So they don't seem to be bothered by the MEERs at all. And in addition to saving water from evaporating, the MEERs also cool the water substantially by up to 10 degrees Celsius. So you can imagine if we apply this technology to coral reefs, we could potentially save them from bleaching, because 10 degrees Celsius is quite a lot. So in summary, let's say we covered 85% of the global's hydroelectric reservoirs. We could save 30 cubic kilometers of fresh water. That's 25% of the global deficit. We could also, by virtue of reflecting away the light that would be otherwise absorbed by the reservoirs, we can reflect away 29 terawatts of global warming power. That's 2% of the problem. And if we covered 85% of all the freshwater reservoirs, we could more than solve the freshwater shortage problem and also address about 10% of the global warming problem. So what about the remaining 90% of global warming, the power that's driving the warming? We have to use land, obviously. So in this field, you're seeing on the right field experiments that are taking place in an airport in Plymouth, New Hampshire. So MEERs have been assessed to be not dangerous for pilots or planes. So where do we get all the materials to make all the MEERs? Well, I was just biking in a city here, and generally when you go to different places on Earth, there's a plethora of plastic, glass, and aluminum cans that just scattered around. But to us, that's a very important resource, material resource, to build out this infrastructure. So at MEER, we recently prototyped a system based on glass, bamboo, aluminum, and the recycled plastics. So a system weighs a total of 80 kilograms, but it has a surface area, MEER surface area, of 70 meters squared, and that can offset the warming impact of 7 tons of CO2. And in terms of the emissions during the manufacturing, we have about 70 kilograms of CO2 emitted during the manufacturing from the curbside pickup of the recycled material, and also including transportation of the infrastructure over 1,000 kilometers to the end user. But the amount of carbon that's embodied in the infrastructure, both in the bamboo and also in the recycled PET and the high-density polyethylene, is roughly double that of the embodied carbon emissions in the manufacturing process. And we'll go into a metric which is called a cooling return on investment. And this system achieves a cooling return on investment of about 3,000, meaning for every joule of energy you spend to build a system, you can remove from planet Earth 3,000 joules of energy. And the cost of this system to offset 7 tons of CO2 is $100 at small scale using off-the-shelf component and a personal 3D printer. So globally, if we want to basically take care of further warming issues by offsetting 50 gigaton equivalent CO2 emission per year, if we had access to all the PET, the plastics, the glass, and the aluminum that's currently going to landfills, we have enough resource for this project for canceling further warming on planet Earth. And the energy that's necessary to build out this infrastructure can be found just by controlling leakage that's currently coming from improperly managed food, decaying food, and also from the fossil fuel infrastructure. So if we have time, I will end with one important metric that can be used to assess all climate change mitigation strategies. So the central problem of global warming is that we have a continuous power of roughly between 500 to 1,500 terawatts of power driving the warming. So the upper bound, 1,500, includes the portion that's currently masked by aerosols. The problem is that humanity only has access to 18 terawatts, and that's everything that we do. So obviously, we're trying to perform a level of warming that's much larger than the technical fossil fuel power we have access to. So no matter how you slice the problem, what you have to do is to invent a cooling system that can, for every joule that you can put into the system, remove 100 joules from planet Earth. Obviously, we have to also continue to live our lives. So in the very optimistic case, where we can use only 10% of the energy to perform the process, we need a cooling return on investment at least 1,000. So an air conditioner is about cooling return on investment of 3. And the very famous direct air capture achieves about 100. So it's basically 10 times too inefficient to be climate relevant. So in summary, most of the things that you have heard, direct air capture, green roofs, or carbon storage, is way below the threshold 1,000 for feasibility. And the only things that can work are direct cooling methods, for example, potentially including MEER. And with that, I'd like to show that birds and mammals interact with experimental mirror fields, and they don't seem to be bothered by them.
Yeah, thank you for getting through a lot of important content there in a very short space of time. I think what's really important is that complete climate honesty throws up these issues, such as the impact of cleaning up our air and what it's going to mean for people who live in cities in the global south and who don't have access to cooling systems. And so we do really need to think creatively about what to do about that. I want to say something about how we are beginning to see some more climate honesty, complete climate honesty for some more top scientists just in the last few months, and how that actually is a real challenge to the IPCC and to the UNFCCC. Top scientists are now admitting the plausibility of bad to worst case scenarios. Papers like Climate Endgame, exploring catastrophic climate change scenarios. Climate Change and the Threat to Civilization, another paper recently out. And also the World Scientists' Warning of a Climate Emergency 2022. I'll just quote from the top one. There is ample evidence that climate change could become catastrophic. We could enter such endgames at even modest levels of warming, facing a future of accelerating climate change, while blind to worst case scenarios is naive risk management at best and fatally foolish at worst. So I do recommend that you have a look into that. What we're seeing actually then is in the peer-reviewed top scientific literature in 2022, what some scientists have been saying and other scholars for quite some years. For example, 2 years ago, over 500 scholars signed a public scholars' warning on societal disruption and collapse, which asks not just for the study of these bad to worst scenarios, but also to actually consider how we can begin to prepare for societal breakdown, disruption, or even possibly collapse. If you're interested in this, I recommend searching online for either climate honesty or climate brightsiding. But to end, I want to talk to you about something we're calling the scholar's oath to the future. The climate science consensus over the last years failed to predict the levels of volatility and damage that we're seeing. The most concerning science was sidelined, yet it's proving to be closer to reality than the past consensus. Now, the reasons why this establishment climatology, we could call it, failed to prioritize communicating bad to worse scenarios must be learned from as we're entering this new troublesome and scary, to quote The Guardian, time. And that learning must include scholars like myself and climate scientists, climate communicators and journalists reflecting on the past choices we've made about being cautious and reticent and pushing away the information that we don't want to consider because it's too troubling to us and the choices we've made. There is a risk that massive new funding is going to distort this sense-making process. We definitely need more radical approaches. So I want to tell you about something that 165 scholars have signed to launch here today. They come from 34 countries, and it's called A Scholar's Oath to the Future. So I'm going to read it publicly for the first time today. This is an apology and an oath of renewed commitment. It's an apology from me and my fellow scholars to you, the younger generations whom we are meant to serve. It is also an oath to learn from our past mistakes as we seek to better contribute in future. That future is bleak. You amongst the younger generations are clearer on that than many older people. You know that the total pollution and devastation has exceeded the planet's capacity to cope. You know that today's dominant economies compel that destruction to continue. You have a clearer sight of the situation than most people older than you because you are less compromised in how you assess this bad news. You are less likely to assume the future will be like the past. You're less likely to keep quiet about uncomfortable ideas for fear of hurting your income, reputation, or influence. You are less likely to try to believe something because it might numb your own pain. That is because you must live in the future that will exist, not one that many older people prefer to imagine when they dismiss your negative thinking. Scholars from around the world in many disciplines have known for years that the trends are in the wrong direction for humanity and life on Earth. Whatever corner of the world we live in, we have seen how our efforts to reverse worrying trends have not been working. We ignored all of that to allow credible lies to be put to policymakers, senior leaders, and the general public. We justified our complacency to ourselves with a variety of explanations that put our needs, pleasures, and fears first. And we blamed powerful others rather than our own part in this charade. Today, the rich countries, large corporations, elite institutions, and mainstream media all support the credible lies that subdue us so that we do not rebel against the global economic system. These lies form the modern face of processes of domination and exploitation that have existed for centuries. But today, we promise not to compromise anymore. When there is unsettling analysis, we will share it. When there is injustice, we will name it. When there is distortion by national or corporate interests, we will challenge it. If we fear a backlash, then we will both name that fear and overcome it. Then if you within the younger generations are critical of our efforts, we will respond with curiosity and seek to make amends, because we recognize that our role is to contribute to your future. So myself and my fellow scholars are sorry for our own part in not helping enough in the past. We promise to learn with you about how to reduce harm, uphold universal values, and enable futures that may still be possible. Therefore, I will tell others of this apology and oath and promote mutual support. Then every year, I will publicly reconfirm this commitment to you. That's the end of the Scholar's Oath to Our Future, which also Dr. Ye Tao has signed along with 165 of us from 34 countries. And we're going to be looking forward to engaging young people in how we make real on that renewed commitment. And Ye's already doing a lot of that, I know, with young people playing a key role in getting you to this far, and with the experiments and research you're doing. So thank you on behalf of the Facing Future team. Thank you, Ye. Cheers. So